Hi students, if the coefficient of friction between two blocks of masses 2 kg and 5 kg are mu static is 0.52 and mu kinetic is 0.50, in how much time the upper block lose contact with the lower block? Take g equal to 10 meter per second square is given. Now you can look at the diagram. A 5 kg mass is kept over a smooth surface and above which a 2 kg mass is placed. A force of 20 Newton is directly acting on the 2 kg mass. Now we have to find the acceleration of these two masses separately. So for that, let us begin with the frictional force between the 2 kg mass and the 5 kg mass. So the static force of friction Fs is equal to mu s. This is due to the first mass, okay? So mu s into m1 into g. So mu static is 0.52 into m1 is 2 kg and this is into 10. So this is 5.2 into 2 is 10.4 Newton. 10.4 Newton, okay? So this 10.4 Newton is less than this 20 Newton. Therefore, M1 will move, okay? It will move over M2. So this frictional force is less than the applied force. Therefore, M1 is going to slide. It is going to slide over the mass of 5 kg. Okay, we have to find the acceleration of the first mass, is it not? So we need to find the force of kinetic friction. So F kinetic on the first mass is equal to mu kinetic into m1 into g. So mu kinetic is 0.5 into mass is 2 into g is 10. So this is now equal to 5. 5 into 2 is 10 Newton. So this 10 Newton of force is acting in a direction opposite to the applied force. So this is 10 Newton. So this is the free body diagram for the first mass 2 kg. 20 Newton is the applied force and 10 Newton is the kinetic frictional force which is opposing its motion. So the net force, okay, the net force acting on the first mass is equal to 20 minus 10 and that is equal to m1 into a1, okay? So m1 into a1. So m1 into a1 is equal to 20 minus 10 is equal to 10 and m1, what is m1 is 2 kg. So this is m1. So 2 into a1 is equal to 10. This implies a is equal to 5 meter per second square. So a1, the acceleration a1 is equal to 5 meter per second square. That is the acceleration of the first mass. Similarly, we will find the acceleration of the second mass. For that, there is no direct force acting on the second mass, isn't it? The applied force of 20 Newton is acting only on the first mass and there is no direct force or applied force acting on the second mass. But this 10 Newton of the force, 10 Newton force of friction, kinetic friction, this will be acting on the 5 kg mass as a reaction force. So for this force 10 Newton called action force, there will be reaction force acting on the second mass. So this force acting on the second mass is also equal to what? The reaction force of 10 Newton. Okay, this is the one and only force which is going to accelerate the second mass. Therefore, this 10 Newton must be equal to this 5 into a2. Okay, so now 10 Newton or 5 into a2 is equal to 10 Newton. Therefore, a2 is equal to 10 by 5 is equal to 2 meter per second square. This is the acceleration of the second mass. Now, when the first mass is moving over the second mass, there is a relative motion between A and B. and there is a relative acceleration of the first mass with respect to the second mass. So that relative acceleration, okay, relative acceleration of the first mass over the second mass is denoted by A1, 2. So the relative acceleration of the first mass due to the second mass. So this must be equal to A1 minus A2, and this is equal to A1 is 5. So 5 minus A2 is 2, and this is equal to 3 meters per second square. So this is the relative acceleration. With this relative acceleration only, the first mass of 2 kg is covering or moving or sliding over a distance equal to 37.5 centimeters. So this is also equal to 0.375 meter. So this much distance the first mass is going to cover before falling. See, what is the question? It will lose contact with the lower block. So when will the 2 kg mass lose contact with the 5 kg mass? When it travels or slides through a distance of 37.5 centimeter, it will fall down and lose the contact. So we have to find out in how much time the 2 kg mass is going to slide over the 5 kg mass. Okay, this time has to be determined. So it is moving with the relative acceleration of 3 meter per second square. So the initial velocity of the mass is taken as 0, and relative acceleration of the first mass with respect to the second mass is taken as 3 meter per second square, and the distance it is going to cover is equal to 0.375 meter. So centimeter is converted into meter, and that is 0.375 meter. So what is to be found in how much time it is going to slide? Okay. So for this, from the equations of motion, I can use the second equation of motion. S is equal to ut plus half into a t square. Here instead of a1 with respect to 2 I have to substitute. So first term u equal to 0. Therefore this will be equal to what? Half into a12. a12 is what? 3 meters per second square. Okay. Into t square. And the left hand side, instead of distance, how much we have to substitute is 0.375. So 0.375 meter. Okay. So this 0.375 is equal to 3 by 2 is 1.5. So this is 1.5 into t square. So t square is equal to 0.375 divided by 1.5. So this is equal to 0.25 will come. 0.25. So t square is 0.25. Therefore t must be equal to square root of 0.25, and this is equal to 0.5 second. So in a time equal to 0.5 second, half second, the first mass 2 kg will slide over the second mass and fall down, so that it will lose the contact with the lower block. I hope you must have understood well. Fine.